So suppose we want to find a particular solution of the differential equation y double prime minus 4y prime minus 12y equals 3e to the 5x. Step 1 always is to solve the associated homogeneous equation. So y double prime minus 4y prime minus 12y equals 0. We find our characteristic equation, r squared minus 4r minus 12. It factors into r minus 6, r plus 2. And so we have as our roots of the characteristic equation 6 and negative 2. Therefore, our complementary solution will be c1 e to the 6x plus c2 e to the minus 2x. And so our two linearly independent solutions of the associated homogeneous equation, y1 is e to the 6x, and y2 will be e to the minus 2x. Great. Now, in order to find the particular solution, we start by finding the Wronskian. So we want the determinant of the 2 by 2 matrix, whose first row is y1 and y2, e to the 6x and e to the minus 2x, and whose second row is their derivatives. So 6 e to the 6x minus 2 e to the minus 2x. We compute that determinant, e to the 6x times negative 2 e to the minus 2x minus e to the minus 2x times 6 e to the 6x. So we're going to add exponents and clean it up, and our Wronskian is going to simplify to negative 8 e to the 4x. All right, so let's start with these integrals. That very first integral, we have minus the integral of y2, which is e to the minus 2x, times f of x, which is 3 e to the 5x, divided by the Wronskian, which is negative 8 e to the 4x. So when we clean this up, our coefficient that we can pull out in front is a positive 3/8. And then when we clean up the exponents, we get an integral of just e to the minus x. So this integrates to a minus 3/8 e to the minus x. Not too bad. Now we're going to do the same game for our second integral. Remember that our Wronskian was negative 8 e to the 4x. So our second integral is the integral of y1, which is e to the 6x, times f of x, which is 3 e to the 5x, divided by that Wronskian, negative 8 e to the 4x. So the constant that comes out in front is a negative 3/8. And when we clean up the exponents, we get an e to the 7x. So this integrates to negative 356 e to the 7x. Now we'll put the pieces together to build our particular solution. So for the particular solution, that first integral was negative 3/8 e to the minus x. y1 is e to the 6x. The second integral was a negative 356 e to the 7x times y2, which is e to the minus 2x. Clean up those exponents, subtract these two pieces together, and we get a negative 3/7 e to the 5x. Now, as a final note, if you look back, this is the same answer that we got in example 1 when we were reviewing the method of undetermined coefficients. So because the f of x in this case was a simple exponential function, either method works. The method of undetermined coefficients or the method of variation of parameters. Probably the method of undetermined coefficients is a lot easier. I just wanted to include it here so you can see another example of variation of parameters and one where the integrals were a little bit cleaner, and so that you can compare the two methods and see that you get the same answer either way. Great. So that's all for this video, and let me know if you have any questions. Thanks so much. Bye, guys.